Hello everyone, this is Luis Montejo. Today I'm walking you through the release of reqpy version 0.4. This update introduces a complete methodology for developing spectrally matched records. It allows for simultaneous two-component matching of orientation-independent target spectra while satisfying minimum Fourier amplitude and power spectral density requirements. So let's dive into the code and look at what is new. First, let's do some quick housekeeping. If you have used reqpy in the past, you will notice the repository has been cleaned up. We have revamped the entire suite of examples, expanding it to 8 fully documented scripts that take you from the basic single component matching all the way up to advanced multi-stage compliance. To improve clarity, some of the core function names have been updated, and they now return an extended comprehensive output dictionary. This means that you no longer have to manually recompute intermediate steps. The dictionary hands you the adjusted acceleration histories, the computer response spectra, and the frequency domain spectra all in one place, ready for plotting. Another highly requested addition is explicit control over the baseline correction routines to handle velocity and displacement drifts. When generating your records, you can now define the baseline method parameter directly. The default option is now a 6th-order polynomial matched to the displacement history, aligning with the approach used by the USGS. We have also added a piecewise baseline correction method for velocity, which automatically defines nodes based on the accumulation of areas intensity. And if you prefer the classic method from previous versions, is still fully available, or you can select none if you want to handle the baseline correction yourself. Now let's look at the primary capabilities introduced in this release, starting with example 7. This script demonstrates simultaneous biaxial matching. We are taking two horizontal components and modifying them so the resulting RotDnn response spectrum matches a specific target. We are also injecting targeted time frequency domain energy to ensure the orthogonal acceleration time histories comply with a minimum power spectral density function. This prevents the energy depletion that often occurs during spectral matching. This is the main function. Notice that in the adjustment mode, we have specified PSD to satisfy a minimum target PSD provided. This function returns a dictionary with all main results from the matching. I call it the dictionary results. And you can extract the result from the dictionary and also directly feed the plotting function. This is the plotting function. The main parameter for the plotting function is the dictionary that came from this other function. So if we run this, we got 4 plots. The spectra plot where we can investigate the goodness of the match. Notice that the RotDnn is closely matched while the PSD is in compliance. The time history plot shows acceleration, velocity, and displacement histories for the scale and the spectrally matched components. This plot also shows the normalized cumulative squared acceleration, velocity, and displacement. The values shown correspond to the maximum difference with respect to the seed record. This polar plot of spectral amplitudes show that the directionality of the seed is well preserved. And lastly, this is another way to measure directionality through the RotD100 over RotD50 ratios and the directionality spectrum. Finally, example 8 presents the complete methodology. Here we use the same function used in example 7. But this time we use for the adjustment mode, we specify both so that this executes a full 3-stage process. It will first closely match for the RotDnn PSA, then adjust for a minimum fast Fourier Amplitude Spectrum, and finally adjust to satisfy a minimum PSD. Notice that we use the same function to generate the plots, which will now also display the Fourier-related results. So let's run this. We got the same 4 plots, but this time the spectra plot also shows the compliance with FAS. The time history plot has an additional line showing the record after the FAS adjustment stage. Same for the polar plot and the directionality spectra plots. There is a line for the record after each of the 3 stages. PSA matching, fast adjustment, and PSD adjustment. All of these upgrades are live right now. You can upgrade your local installation using pip. The complete theoretical framework and algorithms driving this update are detailed in a new preprint available on arXiv. I have placed the DOI link and the GitHub repository link in the description below. Thank you for watching, and let me know in the comments or on GitHub if you have any questions or suggestions.